All right, good morning and welcome to another day of learning with Miss Tia. Today is Tuesday, May 5, Cinco de Mayo. Did you know that Mayo is Spanish for May and Cinco is 5 in Spanish? So Cinco de Mayo, the 5th of May. A lot of people eat tacos on Cinco de Mayo. Ooh, and it happens to be a Tuesday, Taco Tuesday. So I'm telling you to go eat some tacos today. How fun is that? That's one of my favorite foods to eat, tacos. All right, so we are going to finish up with the 3 states of matter today. So what are the 3 states of matter that we have been talking about? Do you remember? A solid, a liquid, and a gas. Remember, we are made up of matter. Humans are. The table that you're sitting at, the chair that you're sitting on, the computer that you're looking at, everything is made out of matter. Some things are solid, like blocks. Some things are liquid, like something you drink. And some things are gases, like the air that you breathe. Okay, so solid, liquid, and gas. Hopefully you've enjoyed our experiments the last couple of days. We're going to do one more experiment today to kind of summarize our solid, liquid, and gas. So today will be a fun experiment today as well. All right, so we're going to do a little matching activity. So I'm going to show you some pictures, and you're going to tell me if it's a solid, a liquid, or a gas, and we're going to put it in the right spaces. And I'll put a link in the description of the video, so if you want, you can print it out and do it right along with me. All right, so let's go ahead and get started. So let's get started with our good morning first. Good morning to you. Good morning to you. Good morning to... I know who's out there. William. Hi, William. Good morning to you. Good morning to you. Good morning to you. Good morning to Stacy. Hi, Stacy. Good morning to you. Good morning to you. Good morning to you. Good morning to... Who else is out there? Kaya. Hi, Kaya. Good morning to you. All right. Let's go ahead and get started. First of all, let's talk about the 3 states of matter. For those of you that might not have watched our previous 2 videos talking about the states of matter. All right. So first we have a solid. Anything that takes up space has a definite shape. So for example, our scissors here are solid. They have a specific shape. It doesn't change shape at all. Okay. Scissors are solid. A mouse for a computer is something solid. It has a particular shape, okay? It doesn't change. A liquid. Now, liquids can change their shape. So they take the shape of whatever their container that they're in. So this here, my water takes the shape of being tall and skinny because my water bottle is tall and skinny. I have paint inside here, is ink inside this dabber, and it is a liquid inside, and it takes the shape of the container. Now liquid, if I pour it on the table, it's going to spread out, and you have to clean it up, right? If you spill water or liquid, you have to clean it up because it will just keep going off the edge of the table, right? And then we have our gas. A gas, like if you fill up a balloon, or you have air in your tires. Maybe if you go on a bike ride, your tires get low. You have to put some more air in there. Just the air that you breathe every day. You're breathing gases, air. We did a little experiment with the ice cube on the stove. Hopefully you guys had fun watching that. Watching the ice cubes, a solid, turn to a liquid because they melted because we added heat. And then that liquid, because of the heat, evaporates and turns into a gas or a steam. Okay? So today we're going to do a little bit of matching activity, and we're going to do a little experiment. For the experiment, you will need a container that you can put water in. Now mine's a clear one so you can see it at home, but I'm going to put some water in here. You need a cup, a plastic solo cup will do just fine, and then you need a paper towel. Okay? So what we're going to do is we're going to put some water in our container. And then we're going to do some experimenting with our cup, okay? How air can take space, okay? Like when you breathe in, your lungs, They expand and they deflate as you breathe. You breathe in the air, they expand. As you breathe out the dioxide, your lungs get smaller, okay? Kind of like when you go in the water and you have to take a big breath. You fill up those lungs and they expand out, okay? So water is kind of like a liquid in the fact that it takes up whatever the container is. Now it's hard to see it. When we did our balloon activity, you could see how the balloon filled up with the gas. And it's kind of the same way with what we're going to do today. So our cup here, well, let's go ahead and get some water, and then we'll start doing some experimenting with it. So I want to pose to you a question, because science is all about questions, asking questions. What's going to happen if we put our cup in the water? Will it float? Will it sink? Does it matter which way I put it? If I stand it up, on the side, upside down? And how does air affect my cup, the gases? Now with it open like this, air can fill the cup, but it can also escape. It can get out of the cup. If I turn the cup upside down like this and I put it in the water, can the air escape? Can water get in? So those are some things that we're going to check out today and see what happens. Alright, for experiment today we have a container filled with water. Now I'm using a rectangular container here, so my water is also rectangular because that's the container I'm using. If you have something more like this that maybe you put like Kool-Aid in or juice or something like that, you can use something like this as well. Okay. Alright, so what we're going to do is I have a paper towel that I've kind of smushed. Actually, I might need a different one. So I'm going to smush my paper towel into my cup, just like that. So it needs to be able to stay inside, to not fall out. Okay? So what we're going to do here is we're going to do a little bit of experimenting with our paper cup. Okay? So we make a hypothesis, we ask a question. What do you think will happen when you put the cup in the water? And does it matter which way you put it in? Okay? So how does air affect our cup? That's another question. Now our research is based on experience. Okay, so we're just going to use our own experience of what happens when things get in the water. What happens when things go in the water? They get wet, right? When you jump in the water, you get wet. If I put a paper towel in the water, it's going to get soaking wet, right? So what we're going to do is we're going to just do some experimenting. So the first thing I'm going to do is I'm going to take my cup and I'm going to put it up just like this. And let's see what happens. Oh, it falls over. But it is floating in my water. Now, it is floating. What if I push the cup down? What's going to happen to my cup? It should do what? Because this is open here, right? And when you push something under the water, what happens? Water goes in. So let's check it out. So now my cup has sunk here to the bottom because it's filling up with our water. Okay? So water has filled my cup. As you can see, I can pour it out. Okay? Let's see what happens if I put my cup with the open part down. Do you think it's still going to fill up with water? Well, let's find out. So I'm just going to place it on the top of the water. I'm not going to push it down yet, okay? So I'm placing it on the top of the water. What's happening to the cup? It is floating on the top of the water, okay? So what we're going to do is I'm going to take this up. Here, we'll push it down just like we did before. So I'm going to push the cup down, and it's kind of hard. If you're doing this with me at home, it's kind of hard. Now watch, I'm going to take my hand away and watch what happens to the cup. It popped out of the water. Why did it pop out of the water? Well, it popped out of the water because there's air inside here. Now you can't see it, but when there's air inside there, it takes the shape of the cup, and when you put it in the water, the air is filled inside and it's trapped inside, just like our balloon, how the air and the gases were trapped inside the balloon. So when I try to push the cup down, now I just showed you, if we push our cup straight down, don't bend it to the side, okay, otherwise it makes a different reaction. So when we push it straight down, the air stays inside of our cup, and when we let go, it pops up because the air is inside and it wants to escape. Okay? Now if I take the same cup and I push down on only one side of it. You see how it falls down? Okay, because it's not going down equally. It's not going down evenly. So now my cup has filled with water. So what we're going to do is we're going to do a little magic trick, okay? So you're going to take your paper towel. Let me kind of dry my cup here a little bit. Actually, it's pretty dry. All right. So I'm going to take my paper towel, make sure it doesn't come out. What do you think is going to happen to the paper towel? Do you think that the paper towel is going to get wet, or do you think it's going to stay dry? Well, it depends on how we push our cup down, okay? So let's go ahead and we'll put it on top of the water. It's floating around. Now remember, there's air inside of our cup. So if there's air inside the cup, that means our paper towel is going to be dry. So if I pick this up, we haven't pushed it in the water, paper towel is dry, doesn't come out. So now if we take it and we push our cup down, I'm going to push my cup down, do you think that the cup is filled up with water? Or do you think the cup is still filled with air? Well, one way to check that is we're going to pull our cup out. I'm not going to let it go, I'm going to pull it out. Because if I let it go, then it will fill up with water for sure. So I'm going to pull it out, and we're going to check the paper towel. Ready? 1, 2, 3. All right, here's the trick. Let's reach in, grab my paper towel. Look at there, completely dry. No drips, no drops, completely dry. Because we have created an air pocket in here, and the air is what keeps, see now it's wet. And there's my drip drops, okay? So a paper towel gets wet, it starts to drip drop, okay? So it all depends on how you push your cup into the water. Now if I push my cup sideways, it's going to fill with water and the air will escape. Now did you notice that when you pushed your cup down, you should have seen some little air bubbles escaping. So I'll push it down again. Alright, let's see if Alright, so now I've changed my container. You don't have to do this. I'm just showing you so that you see that it works with a different container. So now my water is no longer a rectangle. It is now a cylinder. It is the round on the top, the round on the bottom, and it's curved around the edges here. So we have our cylinder. Remember we talked about those shapes? So now I'm going to take my same cup here. I'm going to take my paper towel. I got a new one here. I'm going to crunch it up, put it in there so that it doesn't fall out. And I'm going to again put it on top. So you can see it's floating on the top. And then, as you can see, I'm going to push it down, and maybe you can see some of those bubbles come out. Or maybe not. So I have it completely submerged under the water. And if you notice, as you push it down, the water rises. Ooh, and I'm spilling some. Why is the water rising? The water, when you push air into the water, something filled with air, the water rises because you're adding pressure in there and it's filling up, okay? So the inside of my cup should still be dry. Oh, there's some air bubbles there. So I'm going to pull it up, and as you notice, my air goes down. And look at there. Ooh, and I got air. All right, I got water all over the place here. So let me pull out my completely dry paper towel. Pretty cool, huh? So I completely submerged my cup this time. And you can see it was under there, and some little air bubbles were trying to escape, and my water starts to rise. So make sure when you're doing this that you're doing it somewhere where it doesn't matter if things get a little wet, in case the water rises above your container, okay? So as I push air into the water, you can see my water level is starting to rise, okay? And then when I take it up, the water level goes down. Pretty cool. And now I got water on the top of my cup again. Alright, so that was a fun little experiment. Just showing you how air takes up space and a liquid can spill. Obviously here I'm spilling water everywhere. But my solid, what my stuff is sitting on, does not change, does it? Alright, let's move on to our next activity. Alright, for the next activity we're going to do a little bit of matching. So whether it's a solid, a liquid, or a gas. So I'm going to show you a picture and I want you to see if you can guess which column it's going to go in. Whether it's a solid, a liquid, or a gas. Now this activity, if you have a printer at home, if you look in the description of the video there should be like a little arrow. You click on that and that should give you the description of the video. And I'll have the link of this activity there if you would like to print it out and do this along with me, okay? Alright, so remember solid is something like a tape dispenser. It has its own shape and it does not change. A liquid is something that usually can flow, can spill. It takes the shape of whatever the container it is in, so it can change. And then our gas is something like we can breathe. Again, it takes the shape of whatever container it's in as well. Just like it takes the shape of our earth, right? Because it's all around us. Alright, so I'm going to show you a picture and you decide whether it goes in the solid, a liquid, or a gas, okay? So the first picture I'm going to show you is a picture of a balloon. So the air inside the balloon, is it a solid, a liquid, or a gas? Now this one says helium at the bottom, because helium is also another type of, well, I'm going to give it away, a type of gas that fills up a balloon, which makes it float, so it's lighter than air. So when you fill up a balloon with your mouth, when you blow it up, it falls down to the ground, right? Well, helium, because it's light, it's really light, lighter than air is, that's what makes the balloons float into the sky, okay? So helium, or the air inside of a balloon, is you should have said, a gas, right? Because it's filled with air, some sort of air. All right, so I'm going to put that under my gas here. And the next one that we're going to do is an airplane. An airplane, a plane that flies up in the sky, something that you can get into. Does an airplane change shape? No, at least you hope not, right? Especially if you're inside of it. So airplane does not change shape. So airplane has definite shape, and it is something that we would call a solid. So airplane is a solid. You might even have like a little toy airplane that you play with and you fly around, and that is a solid, okay? Our next one is, does anybody out there eat syrup on your pancakes or your waffles? So maple syrup, this syrup here. Now if you notice, the syrup in the bottle and the syrup on the pancakes, it has taken a different shape, right? Because the syrup in the bottle has a container, so it takes the shape of the container, but when you pour it out onto your pancakes or your waffle, it spreads out, right? And it takes the shape of your pancake or your waffle. And waffles, sometimes if it has those little nooks and crannies, those little holes, it fills up the little holes. All right, so our maple syrup is hopefully you're saying it is a liquid. It is a liquid because it can pour and it can spill. All right, so I'm going to put that here in my liquid. So now we have one for each of our states of matter, solid, liquid, and a gas. The next one we're going to do is something that you might drink in the morning or maybe with your meal. It is orange juice. Orange juice you put into a cup. Stop. Alright, so orange juice, something that you might drink, you pour it into a cup. Is that a solid, a liquid, or a gas? Now the orange is a solid, okay? But the orange juice is something you drink. It is a liquid. So orange juice is a liquid. How many of these have you gotten right? Have you gotten all 4 of them correct? I certainly hope so. Alright, let's move on to our next one. How many of you eat cheese? Maybe a cheese stick or a cheese square, or maybe cheese that looks like this on a block, okay? Cheese. Does it go under gas? Does it fill up a balloon? Can you breathe it in? Probably not. No, probably not a great idea. Is it something that you can pour? Now there is a liquid cheese, but this one is not our liquid cheese, is it? It is going to be our block of cheese. So it is something that we eat. We put it in our solid spot, okay? Alright, so how many have you gotten right so far? So we have our solids, our airplane, and our cheese. We have our liquids, our syrup, and our orange juice, and we have air inside of a balloon, which is our gas. So the next one we are going to do is, if I can get it here, is some paint. Paint. So this is a paint inside of a can. Now, is paint a solid? Well, if it was a solid, we wouldn't be able to paint with it, would we? It would, because it's not supposed to be able to change shape. So, is paint a liquid or is it a gas? I believe it is a liquid because liquid can spill. And guess what you can do with this paint? You can spill it all over the place. You have to be very careful with paint. When you are painting, you put something down so it doesn't spill all over the place, right? And doesn't spill on your clothes. So paint takes the shape of whatever it is that you are using. Alright, so the next one we're going to do is, any of you guys have a ball at home, a soccer ball. This is a soccer ball. Or you might have a basketball, or you might have some other kind of ball at home, a kickball. The air inside of here is what we're looking at. So the air that you use to blow up the ball, because like a basketball needs air in order to be able to bounce. Same with soccer ball or a volleyball or a kickball. So the air inside is a gas. It is a gas. So anything with air in it is probably going to float, because like in our experiment that we did with the cup floated, didn't it? And when we tried to push it down, it resisted and pushed back up when we let it go, didn't it? Okay, so anything with air inside is going to float. Okay, all right, so we're going to do another one here. How about, these are icicles. So it's basically ice. So water that has trickled down and has frozen into icicles, but it's still ice. So what is ice? Is it a solid, a liquid, or a gas? Now it is made out of liquid, but when it's frozen, remember it is a solid. So that's going to go in our solid column because ice is a solid. All right, and we're gonna do, let's see, we'll do one more here. How about, she is breathing out air. What is air? Is it a solid, a liquid, or a gas? So when you take a deep breath in, and you breathe out all that air, air is a gas. So that's going to go here in our gas. All right, and that's going to be it for that activity. So remember, you can always do that at home. If you have a printer, you can print it out and do this activity at home as well. Okay, so that's going to conclude our lesson on the 3 states of matter. Hopefully you enjoyed doing our little experiment today with the cup. Like a little bit of magic, right? How did the paper towel not get wet? That was pretty cool. All right, so tomorrow we're going to start on something a little different, but still doing some science. So hopefully you are ready to have some more fun and do some more science tomorrow, okay? All right, so in our next video, I will see you tomorrow. Bye-bye.